Hey everyone. Just before we get started, I'd like to maybe let everyone get prepared for the hands-on lab tonight. So we will be using Databricks to go through a data frame lab. So if you are interested in follow along, you are free to do so. And I just want to introduce how to set up Databricks. You do need to create an account. Um, uh, our speaker Indrani will also go through this again because there might be people, joining at a later time. But, the first half of the lecture will actually be a quick introduction to Apache Spark. So I think you do have a little bit of time to get prepared if you haven't done so yet. So in order to get started with Databricks, you do need to sign up for a community account, right? So you need to go to databricks.com /try Databricks. Let me share the link with everyone in Zoom chat. And when you go to this link, you do need to put in, your, first name, last name. Company email can actually be your personal email. But on the next screen, please make sure that you don't click on get started because that's basically just a free trial and you're going to have like 14-day free trial. Make sure you click on get started with community edition because this is the free version of Databricks, so you get to use it for free, which is great, and it's really good for learning purpose. So make sure you click on this link below to get started with community edition, and then you will receive an email from Databricks, and you just need to click on the link to reset the password, and then you can go to community.cloud.databricks.com to log into Databricks, and Indrani will be teaching you how to get started with Apache Spark, and we'll tell you how to download the data set for tonight's lab. So yeah, if you have time, get set up. We'll go through this quickly again at the end of the presentation before we get started with the lab. All right, so I think it's time to get started. It's a pretty exciting session tonight. I just want to go through a couple of slides, housekeeping stuff. I think we're almost at the end of this, free data course we've been doing since last Monday. And tonight we were kicking off the data engineering sessions, right? So we will be introducing Apache Spark tonight, and tomorrow we'll be introducing data warehouse, and on Thursday we'll be introducing AWS Lambda. And you'll be working with, WeCloudData's data engineering faculty team. And yeah, if you'd like to learn more about WeCloudData and take a free course, you can go to learn.weclouddata.com. This is where you sign up for the free course. This is also how you're going to access the recording of tonight's session. If you missed, last week's sessions on, Power BI, introduction to Python and machine learning, you will be able to self-enroll into a free data course on our learning portal. And if you would like to stay in touch, chat about data science, analytics, and data engineering, and stay up to date with, WeCloudData, you can join the Discord session, Discord channel as well. We have already shared the Discord channel link in through email and on Meetup as well, but I'll paste the link in the Zoom chat again. And lastly, I just want to let everyone know that WeCloudData also is going to launch a new cohort of the Data Engineering Bootcamp on the West Coast, which is quite exciting for us. And Indrani will be, the lead instructor for that. I'll leave it to Indrani to introduce herself because she has an amazing background. So yeah, Indrani, I'll leave it to you to do the self-introduction. And it's going to start in about 2 weeks. And the next cohort of the Eastern, course will start in February next year. So if you would like to become a data engineer, WeCloudData has one of the best programs. All right, without further ado, I would like to pass it along to Indrani. She teach, with WeCloudData, but, she also is the director of machine learning engineering and platform at Loblaw Digital, and she also has worked on many software engineering, big data and data engineering projects in the past, and our students really enjoyed her lectures in the data engineering program. So tonight she's going to introduce data engineering, big data, as well as a hands-on lab on Apache Spark. Thanks, Indrani.
Thanks, Shava. So yeah, I can take it from here. So welcome everyone. So I'm really excited to kind of give this intro to data engineering, which is probably going to be the most exciting and the most apt for today's, I guess, the ecosystem in the data engineering practice. So I think Spark plays a very big important role, apart from, of course, a whole bunch of other things that you would learn to along with Spark and big data tools like, your cloud managed services and things like that. But happy to start off with this free session. In this class, we'll be going through Spark in general, and just about like the how this whole thing started, how big data basically became a very important, big data processing became very important, and how it led to the kind of advent of new technology and where we are today. So from there, I think we'll look at the journey and maybe go through one exercise with Databricks. So let me know when you can see my screen. I'm just going to start sharing my screen right away. Can you see my screen? I think you should be able to.
Yes.
Okay, perfect. All right. So actually, let me do it in the slideshow. Okay. Yeah. So I think we all know that around 2010 or so, we started to see, actually even before that, 2000s was when we started to see a lot of data being generated in general. So around 2010 or so, the internet basically generated, the apps from the internet basically generated a lot of data. So the internet basically then generates about 2 to 2.3 zettabytes of data. This was in 2014. We do a lot more today. Facebook about 500 terabytes of data in 2012. So we're like way past that today. So more and more data across the internet every second is being generated, and it is definitely a lot of valuable information. But the thing is that early 2000s or early 2010, it was very hard to kind of make sense of the data because we did not really have the right tooling. So up until then, I think everybody was like, oh, we're going to be doing databases, you obviously, like, the Oracle, DB2, those companies were big. People had to kind of structure the data, store it only in a database. It was all siloed. So if you had multiple databases, you could have multiple databases. It also required maintenance, DB work, all that kind of stuff. Right. So as the landscape started to grow, we saw a lot of difference, like the variety in data. So the 4 V's of big data are like volume, velocity, variety, and value. This is by basically this. I guess this terminology comes from the Harvard Business Review. There are lots of case studies on how they kind of look at this from a different angle, from the angle of like volume, how much we're creating, how fast are we creating, how much, I mean, mostly like throughput wise, how much is the variety of the data, like, are we talking about transactional data, are we talking about image, voice, text, pictures, graph, this variety of data that we're actually consuming, as well as like generating using these apps. So how do we kind of deal with this data and process large amounts of data, and what value we derive from it, right? There's no question that, we derive value from it, but there is no we can't like quantify the value unless we're able to process this data, right? So that is actually the start of that is basically how, we started thinking about the data, and we wanted to basically find a way to convert all this data into some kind of an actionable insight, right? So imagine you had all of this data. You could make it so much more useful for targeting people, for personalization, for recommendations, for I guess like better predictive analytics, better forecasting it, right? So these things always existed, but we could do it with a lot more confidence, a lot more data points. As you know, the more data points, the better it is. So imagine like not just using one data set, but also combining multiple data sets to achieve any one of these the problems that we're looking at. So mostly everything related to this was all about turning this data to an actionable insight, right? So predictive analytics has always been there, but if you look at the data and AI landscape of 2019, I mean, this is 2019. I mean, for those of you who are interested, this particular graph is being generated by HBR almost every year since I think 2017 or so, 2015 or so, and each year you'll see that more and more tools get added to this. So it's kind of small, but you see there are a lot of different companies, and they're all kind of broken down. All of these are big data, achieving like data and AI landscape, but they're all kind of like different. Because some of them are mostly to do with analytics, some of them are mostly to do with like ETL, some of them are mostly to do with machine learning automation, some of them could be mostly with running some kind of deep learning methods. So we have a variety of these frameworks and tooling down here, but we also have a variety of data sources and APIs, which means that because today we have a lot of like tooling to kind of process this data, a lot of companies have actually been in the business of actually generating data and actually selling data. So it's almost like some third-party data giving you, like, so for example, Bloomberg giving you its data source as one of the source for which you pay. So a lot of companies have emerged whose sole business is basically to kind of provide you data for you to kind of use those data points along with your data points to achieve something else, right? So it's pretty huge. You'll also find a lot of cross infrastructure analytics analytics tools, like some tools like SAS that you've probably heard of if you were working in a bank or insurance company. Those are also going more and more cloud based. So you'll see that apart from that, you'll see a lot of like companies like Cloudera, Hortonworks, who were actually initially the ones that offered an ability to run distributed programming such as MapReduce on infrastructure or like servers that were on-prem or on a data center. Today, all of that has also been moved into cloud. So you'll find these two different varieties of tools, typically one on-prem and one on cloud. So with the cloud, it also kind of becomes more exciting because you have all these cloud tools offering like some managed services that offer similar capabilities as well. So anyway, so applications are all across like all kinds of industries, advertising, real estate, like government, agriculture, transportation, life sciences, healthcare, of course, e-commerce, like being the biggest of almost all things here. And then and then if you want to look at more by kind of by role, you could look at visualization companies or BI platforms, or specifically computer vision. So there's a lot of different companies. So I mean, it might sound very daunting, but I can assure you that if you learn a few I guess principles and a few tools, you can almost pick up any other tool. So I think that is what our course is aimed for. We know that the world out there is very, very diverse. So we want you to be able to kind of learn the most important skill set, so the rest of them becomes almost second nature for you. Okay, so this is how the landscape looks like in 2019, but feel free to go and search for one that is most recent as well, and you'll find it really like lots of different applications here. So we'll talk about evolving tech stacks. So I want to kind of I want to talk a bit about what happened in the past and where we are today, right? So you'll see that mostly when big data started to become popular, and people started to use people typically started to use open source projects such as Hadoop. I'm not sure if you know about Hadoop, but you can go look up for Apache Hadoop. Apache Hadoop was an Apache project that was first started out to like, there is actually a white paper by Yahoo, and they were the ones who first started out basically open sourcing this framework that will let you run jobs in a distributed fashion. So the main goal of this framework was use horizontal scaling, which means that in order to achieve a problem, you simply don't throw compute at it, but you actually parallelize your job across different computers. Okay, so imagine you had like a query that you're running on Oracle, and you lose capacity, and it's taking a long time. You throw compute at it, you basically throw more compute at it, and then it becomes faster. That's one way of scaling things. The other way of scaling things is to have, it's called horizontal scaling, where you basically add more and more nodes or computers to your cluster. A cluster is nothing but you create a cluster by adding a lot of a bunch of computers or servers together, and using the resources across the computers in order to achieve your problem. But for that, what happens is every single problem that you take up needs to be broken down into a system where you can assign repetitive tasks to each one of these computers, so they all work on a task, and then there is a component that is responsible for collecting the results from all of these different servers, and then wrapping them up, and then presenting it as a result. Okay, that's basically in a nutshell, if I have to say, what Hadoop or MapReduce did at one point in time. So the MapReduce itself came with like a bunch of different components. So it had a resource manager called Yarn. The Yarn was basically something that was responsible for allocating jobs, as well as like allocating jobs to multiple computers, trying to keep track of like how much each job took in terms of compute, all that kind of stuff, coordination, all of that, right? So basically there was a Yarn, and then the rest of the software was basically, the core compute was basically MapReduce. Okay, this was MapReduce. So every single problem that you solved on a Hadoop framework, which was later offered by companies such as WeCloudData or Hortonworks or MapR, which probably you probably heard of it, but if not, those were the yesteryears of today, like today's cloud that people are using in order to run this framework. Okay, so every job that you wrote, whether you wrote them by hand using Java, or whether you wrote them using Scala, or whether you wrote them using a query, everything would under the hood get converted into a system where it would be broken down into smaller tasks, and the tasks would be distributed to multiple computers or nodes in your cluster. They would all action on those items, and then they would get back the result, and then the result would be wrapped up and then given back to the user, right? So but the problem is that all of that was in code, and in order to kind of make use of this framework, there came more other small applications built on top of Hadoop, which were responsible for making your life easy as an end user, right? So whatever I spoke so far looks complicated, right? It sounds complicated. It only sounds like devs can do it. But what about what about those analysts who wrote queries on SaaS or microservice or created graphs or reports? That functionality was being lost. And also it was a very big learning curve for all of these folks to learn a new framework and a language. And hence, all these small other applications came up on top of MapReduce or Hadoop, right? So basically, Hive was actually a service API. It is basically it's like a service where you can run your like SQL queries. They're called HiveQL, just like SQL. And you can run those queries, and under the hood, just because it's all running on MapReduce or Hadoop, it would have gotten converted into the source code that the framework can understand. But as far as the end user goes, it almost looks like he's writing a SQL query, right? So Pig is another small API service that came up in the same Hadoop. It was mostly like a semi-structured language where people people could write some query like tasks to be done. Mahout was mainly used for running small like machine learning models on top of data. So basically, you should understand that all of the data underlying the Hadoop was stored in a file system called HDFS. It's called the Hadoop distributed file system. So it is distributed, which means that all these computers in your cluster could access it. It's distributed in nature, and there is underlying technology on how to kind of make sure that the data is all distributed. The data, if data from one node goes down, like if a node goes down, how will the data be? How to make sure fault tolerance is taken care of? How do you make sure that the replication is taken care of? All that technology comes within it. So basically, in a nutshell, if you were to call what was Hadoop, it was basically the combination of MapReduce, HDFS, and a resource manager like Yarn. That was the beginning, and all these several smaller services that came within the whole framework, right? So that was how it all started off in the beginning, right? So the Apache version of Hadoop was very hard to kind of maintain because there were a lot of different components, a lot of different upgrades, a lot of different packages, dependencies, so many different things. So companies such as Cloudera and Hortonworks, they kind of became very popular because they would give you like these they would actually make available these distribution to different people, like for you to use. So you would actually pay them, get yourself a license, and then use their software. So they're basically running the same software, but they take care of all upgrades and patches and all that kind of stuff, right? So over the period of time, what happened was slowly MapReduce became not so popular because of certain limitations. Spark became popular. Spark has also gone through its own set of like changes, but it's just generally speaking, just Spark took over the whole core compute piece of it, and it became very, very common that you saw people running Spark instead of MapReduce just because of its efficiency. And but then the resource managers remain the same. Now, Mesos and Kubernetes are two new things that you see today. I mean, please treat this as a story because it can look like a lot of components, but it's just different advancements over the same framework over the period of years. So now imagine instead of having physical computers, you had data centers, and you had to basically have these nodes across data centers. Then Yarn got into the job, and then there came Mesos. So people slowly started to move away from this whole concept of data being separate from compute, right? You had compute somewhere, but you had data somewhere. You wrote your you can access data from anywhere, but you can have your compute run through a certain computers and things like that. So Spark basically came with its own framework. It first started with again, similar to MapReduce, it has its own SQL, ML, streaming engine, and basically graph frames, which is a graph processing engine. And it looks like it kind of took over, and it has almost stayed the de facto framework for large scale analytics since then. Okay, so you'll see that Spark is by far the most common analytics framework across the industry today, even today. Spark had also a lot of different changes. There was Spark streaming, then it was replaced by structured streaming. I think even graph frames and GraphX, there were multiple versions of these service APIs as well, but the underlying concept remains the same. Okay, we'll go over what Spark is and an example, so it'll become a lot more clear for you. But also, just generally speaking, Spark is one of those things that you can set up your own cluster and run it on Hortonworks or Cloudera, but you can also run it on the cloud, which is why and then you can access any data, like basically data from S3 buckets or data from Azure Blob or Google Storage, and you can run your job, right? You can read your data, do a bunch of operations operations using it. So imagine having to run a big query or a query like job where you're reading data from a particular location. It can be structured, it needn't be structured, it can be unstructured, as long as you're able to write a job and do any kind of actions on the data, be it group by, order by, sort by, or more complex transformations, time window transformations, I don't know, like running other regex operations or writing other functions. You want to apply anything on the data, you're able to do that using Spark. The only difference between a normal job that you would run in say in using a language such as Python or writing a SQL query is that they are all not distributed in nature. They all execute them in a serial fashion, whereas Spark executes them in a distributed fashion. Okay. So the advantage of that is you're doing a lot more things in parallel. So parallelism is the key here. And hence the idea is that because you're doing things in parallel, you're able to speed the process. Okay. So basically so that's where we are today. And you'll also find that there are other managed services on the cloud today, such as Databricks, which is basically running Spark, but they provide you like basically an out of the box software as a service offering, where you don't have to basically take care of the infrastructure or the maintain the infrastructure, but you can just go run your jobs as an end user on it. So that's available as well on Azure or Google Store, GCP and or AWS. But they also have AWS and GCP and Azure. They also have their own serverless versions of Spark available. So you see how there is a lot of commonality in between all these services that are being offered across different cloud services. And that's why we aim that you learn the framework well, so you're able to run literally the same queries on any one of these cloud providers, and you're still able to kind of like get yourself doing that job. Any questions so far? Have you heard about Spark? Anything that you want to share so far? No, I'm just speaking a lot, so I thought I'll pause for a bit. Yeah. Cool. Okay. So this is how the basically the landscape has evolved over the period of time. So, oh, okay. I didn't realize there was more animation. Anyway, so MapReduce was gone, all this was gone, and so Spark remained. I think we covered that in our story. So that is what it is. Okay, so just in general, we'll look at how just like how I was saying that in AWS you do have you can run this in different cloud infrastructures. But the idea is, why are we talking about this in terms of cloud, right? Because today we know that a lot of these data services have actually moved to cloud. So a lot of companies are adapting to cloud a lot more, which means that every time you run a particular software on your own servers, which were located somewhere, on somewhere that your basically data center was, we're all kind of relying on the cloud, right? So basically we rely on procurement and the infra on the cloud, but it also means that a lot of these different capabilities for processing the data have also moved to the cloud. So we're only talking about Spark now, right? We're only talking about Spark, but after the Spark, what happens? After you run a job in Spark, what happens? Before you run a job, what happens, right? What is the upstream process? What is the downstream process, right? So we have a variety of variety of those, I guess, a combinations of upstream and downstream processes. And you'll often see that, they're all within the cloud, or, there is some way you ingest something like some data to the cloud and you do a bunch of different operations. So you'll see that within every cloud provider, there are similar kinds of like managed services that provide you capability to do certain kinds of things, right? So for example, this is AWS. This is how exactly the, big data landscape of AWS looks like. You'll have a similar thing happening in Azure as well as GCP. So imagine you have an on-prem data warehouse such as Oracle, where it's your enterprise data warehouse, and you are running it in SaaS, and you're doing some kind of analysis in SaaS. This is a very, very common I guess pattern that you will see, but there are other services where you can basically sync the data over to somewhere on the cloud and have, you know, um like a warehouse on the cloud, right? But there are lots of teams that are just responsible for like bringing the data in from, say, something like an EDW, which is on-prem, to the cloud. So you'll see that you'll go through a variety of different tools. AWS provides you certain tools or services that let you kind of sync the data, put it into some kind of like a raw landing zone, further make sure that you're able to run a whole bunch of ETL jobs for cleaning up stuff, or go through for some transformations. And then there's most likely that you'll also want to do a lot of different Spark jobs on it, which could be either Spark, which could either be run in batch, or it can be either run online. Okay, I'm not quite sure if you understand what a batch and online is, but imagine you're getting data, you're bringing in large amounts of data every, I don't know, overnight, every day at 10 o'clock in the night, and then you're running a huge job which is doing some kind of a transformation on the data, and then you can finally put it into a warehouse, such as Redshift. Redshift is the name of a data warehouse, like a big data warehouse within AWS, similar to, say, something like Hive that we just saw. Okay, so Hive that we just saw. Now another thing is, imagine you don't want to bring it in batch, but you want to be able to stream the data in and do those operations or transformations on the data as they arrive. So AWS also provides you certain services such as Kinesis that are responsible for streaming. Like this is like one of those services which is also distributed in nature, that is responsible for reading data from one place and writing data to another place and stream them as the data comes in. There are several kinds of data patterns on how this is implemented. There is we'll learn more in the class as well about publisher, subscriber, and other kinds of data patterns and how data comes in, and then you can stream them, and as you stream them, you can do a lot of transformations and put them into a data warehouse such as ETL, Redshift, to do your ETL operations or your ELT operations. Once the data lands in like one of these data warehouse, this becomes your source of truth or your data warehouse on the cloud. Something akin to your data warehouse on the on-prem, right? So then you can run a bunch of queries on them. You can create multiple views on your warehouse. You can give access to your business teams to run queries. You can run more derived tables. You can create more derived logics. You can create more insights. You can have you can basically use a service called Athena, which will let you run queries. Basically, it's like this engine which gives you interface to go run queries against this data warehouse, and you can create fancy aggregate tables, derived tables, and also fancy graphs out of it and create insights. So in a lot of like cases, it has almost become like this whole I guess this whole set of like managed services are replacements for Oracle and SAS, but in essence, you're doing a lot more. You have more control over the data. You are not under the restriction that data has to be in a certain format. You don't have to define the schema beforehand. You can bring in the data into your raw landing zone as it is, and then you can do a whole bunch of operations. You can have data as you please. You can have some of them in your buckets, some of them you can have them in a structured format. You can do whatever you want. It gives you that flexibility to kind of play around with data. Also, the fact that the data is completely separated out from compute, it gives you a lot of different advantages, because you can store the data once, but you can use that data to run multiple services like on it. Okay, so you also have furthermore other data science services like ML services that AWS provides. For example, AWS provides SageMaker, which is their managed service for you to run a lot of like automated ML services. You can write them by hand, from the scratch by hand yourself, or you could use some of the AutoML models that are already available there. So you can, like, almost without learning without becoming a data scientist yourself. It enables you to do something very quick and look at your data. So it gives you all of those nice capabilities. You can also have furthermore special use cases that you're doing. You could be having a lot of transformations on data, doing a lot of different things, combining multiple different sources, joining them. You could have a very complex data source. So it also provides you ability to kind of schedule them, create special pipelines, schedule them on time. There's also the concept of Lambda, where you can wrap this whole functionality into a big function and then run them as you please. There's also a lot of concepts such as CI/CD that are built in. So CI/CD is basically stands for continuous integration and continuous deployment. So it also, you can basically kind of format and create a pipeline in such a way that as soon as you kind of commit some new code to your GitLab, it can basically have a cascading effect and trigger down multiple pipelines to run, and all the way up until pushing some code to production or like rerunning something. So you can basically customize what needs to be done. So CI/CD is basically that aspect that lets you do continuous integration and continuous deployment. Okay, so you will see here that the landscape basically involves data sources, some kind of ingestion. Ingestion means it can be like a batch-based process or a streaming, storing it into your data lake, which is data lake is loosely a term used for a place where you store all of your data in the form of like buckets or some kind of storage. Of course, in a large organization, you need some kind of like organization. Otherwise, everything's going to be like really messy. There needs to be some kind of limitations on how much data you can, how much, I guess, data you can, how much compute you have to run queries against the data and so on and so forth. But it's just loosely a term to say where you store your data. Then you do have a catalog, this notion of catalog, which is really essential because, as you know, the only difference between something like an Oracle and something like, the cloud is that in Oracle, you have a schema, right? Everything is bound by a schema, and that's why you're able to run queries. But in the cloud, when you store data as files, but you want to give it a tabular structure where you can run queries, you need some kind of like a catalog that tells you, okay, if you're looking for this data, it is somewhere here, or if you want to run query against this, the data pertaining to a certain table is somewhere here. You need to know all that information, and you do have a way to kind of prepare data like that. So catalog is necessary. And then you do have a way to run process, like different kinds of processes like Spark Batch or Spark Streaming. And then for analytics, you do have an ability to run queries, or you have the ability to run, I don't know, like SageMaker, and then you can have several kinds of apps built on top of the data that you kind of prepare. It can be reports, it can be something that you would go look like, define KPIs and go look at certain reports, or it could also be certain apps that's running a machine learning service that's giving you some kind of like a result from every call that you make to the app. Okay, so in general, all of this is data engineering. It can look very daunting, but as a data engineer, you could be doing any one of these processes and you could still be called a data engineer. Okay, so which is why I think we'll also concentrate on one aspect in each. I think we're going to cover the entire thing in our course. We will stress on some more than others, but definitely we'll be covering, almost everything in this whole I guess, like this whole spectrum, okay, of tasks to do. Okay. Yeah. So that said, let's actually look at, so this was just me basically trying to tell you last time. This is basically something that is borrowed from Spark. So basically in the past, having, in a traditional system, you always threw more compute in order to scale, but something like, in a distributed architecture, you would definitely, it definitely mean that you're scaling, you're basically adding more resources to your cluster, which means that each one of those computers or your nodes on your cluster basically act for your computer resources. So this is basically what it is in an EC2. EC2 is a service in AWS, which is something that provides you VMs, right? It's like how you go onto a cloud and say, hey, I want a VM. My VM should be so and so. It should have it should have so much RAM. It should have like an SSD, or it should be this big, and it'll give you a cost for it, and it'll say, well, you could have a rental cost for it, but for compute it'll cost you so much, and hence that's how you'll be billed, and you'll give you a computer, right? So you get a server, but there's nothing installed on the server. You start to install everything that you need to run, and then you use it, right? So now if you were running a Python job that was processing a whole bunch of data, and you basically had that Python job inside of this EC2, and now you had a lot of you had a lot more data, it's kind of slowing down. You can add more compute to it. You can, if it was a medium, you can make it large, and so on and so forth. But there's only so much you can do, because Python will only run it one line by line in a serial fashion, right? But what is different from an EMR, like what is different from EC2, is that in EMR, which is where actually your Spark will run, it is an elastic MapReduce, is it'll actually make sure that it will procure a bunch of these different servers for you. It'll make it a cluster. All of this is not seen to your, like, it's not something that you would have to do it yourself. It's not like you would have to configure. It's not like you would have to procure separate servers and run a software on it to make it a server. It'll take care of all that for you. It'll just basically ask you a few things where you can specify, I need my size so big, and things like that. And it'll basically make sure all the connectivity, all these things are talking to each other. It basically installs the software on top of all these VMs, and make sure that creates a cluster for you. And every time you run, it'll also install Spark for you. So by default, it's assumed that you will run Spark jobs in it. There is a way you can start the Spark shell, like any other shell, and start writing code there. Or you could write a job, compile the job, throw the compiled code into one of these nodes and say Spark submit. And you can submit your job. So basically it'll run your Spark job in a distributed fashion. So it'll make sure all the parallelism is taken care of and things like that. But you would have to write it in such a way that you provide all the necessary things to it, like, other dependencies, other packages that are necessary. Of course, you would have to follow a certain syntax. Your job could be either written in Scala, Python, or Java. But the idea is that it gives you APIs for all these different languages. You can choose a language of your choice, and then you can basically throw it on one of these things, and then it'll take care of it. Okay. So that's basically how a EC2 differs from EMR. Yeah, so this is just to show that, sorry, I was just going to go here again in a bit. So what this will also make sure is that, not only it will make sure that the parallelism is taken care of, it will also make sure that the data that you have is stored across the nodes, with some kind of a replication factor taken into it. The reason is that for whatever reason, as one node goes down, you do have some data points in the other two nodes that you can retrieve. Okay, so we'll look into all of this in the class, but that's basically the idea. So there is not only just this notion of running your job, but there's also the notion of the data that is stored, and how you could always make sure that fault tolerance is there. Okay, so let's look at yeah, I think this is an example that's talking about, actually, let's go to the next slide. I think it'll make it much more easy for you. Okay, so now imagine you had a big document, okay, and the big document basically had a lot of words in it, text in it, and you're basically solving the problem where you have to be able to count the occurrence of different words. Okay, so you had a big like a really large file, and this is usually seems to be one of those problems that you think is very simple, but a lot of use cases are based on parsing data. You could have basically logs from a big server that you want to parse. You could have lots of user logs that you generate, or your app generate. Or imagine you are a telecom company and you have a whole bunch of data from like mobile browsing data that you want to make use of to for certain campaign or for an advertisement or whatever it is. Like so much data on transaction, like so much data problems are there in the transactional data. With using the transactional data that you generate, could be users, could be logs, could be your own app. It can be server data. It can be like, I don't know, like data coming out from smart devices, whatever you see, you have a lot of data being generated and you want to parse them. So if you were to do something like a very simple word count, what you do is first split basically this job into multiple pieces, right? You could split it, and you imagine you had three nodes to do it. You could break it down into 3 different pieces and assign each piece to each computer. Now, except there is a method to this madness, right? You would have to, like, if you are counting by eye, you have this natural intuition of saying, okay, I see here 4 wishes, and I see here 2 2s, and I can see here 1 the and 1 u and 1 I. So you can't do that by eye, right? Like I'm talking about really large data. You would have to have some kind of a method to do it. So that's where your map and reduce come into the picture. So the first step is actually a map where you're trying to assign 1 to every word you see. Okay, so that's how you do it. So I comes 1, wish, every occurrence of wish you add a 1, and then 2 you add a 1. Again, there is a wish, you add another 1, and so on and so forth, right? So you do that. Each one of these computers is doing the same thing at the same time. They're all kind of parallel. But what you would do later on is that you would somehow combine them, right? And then you would have another list that each one of your nodes or servers generate. But we do need the numbers or the counts from all of this data, which means the data that is being split among all these tasks. So what you do is, because you have some words that are coming out of each one of these different processes, you basically want to shuffle them and get the right numbers. Okay, so this is a very, very I guess a very layman way of understanding MapReduce, but this is essentially what you're trying to do. So if you look at a common theme in this process, you're seeing that you're giving each node or server do something repetitive and something similar, right? And in the end, you're going to take the results from each one of these servers, somehow combine it. How we combine it, whether there's going to be shuffle, are we going to be shuffling things around? Are we going to, that's a different story altogether. But the whole idea is that you're doing a map operation where you're trying to do something, something like similar. You're doing some kind of a mapping, right? And then you're doing some kind of a reduction operation, right? Look, where you're trying to bring all the results from the mappers and bring it back and calling it, okay, here's my result, here's my combined result, right? So that's exactly where map reduce came, right? So it's called map and reduce. So you'll often find, like in interviews, or like you'll see this common thing, like, okay, what is exactly a map operation, right? You have several kinds of map operations. You have several kinds of reduction operations, right? So group bys, order bys, all that kind of stuff that you typically do in SQL, you can actually see a common theme that you can apply to MapReduce as well. So there is something that you can usually do at a map phase. There is something that you usually do at a reduce phase. Okay, so we'll see all of that also in detail. But in a nutshell, that is what MapReduce is. You'll understand a lot more when we go into the nuances, but this is like, I guess, a cross view of something like a MapReduce. The more detail we go, I think you'll try to get to understand better. Okay, so this portion after combine is going to shuffle and sort them, which means that you see how all the words are like across different I guess servers. So you're able to shuffle them and put bring some buts from multiple places, multiple servers, 2 and those from somewhere else, and so on and so forth, and then finally combine them. How you define these, how you make sure that you're able to shuffle them, there are some algorithms that tell you how to do that as well. But those are smaller details, but just generally, this is what MapReduce looks like. Okay. Any questions so far? I know I'm speaking a lot, but I'll just pause for a second before I go forward. No? You guys are all silent? All right. So let me go to the next phase. All right. So let's actually look at how let's actually look at how this whole diagram that we saw previously, right? Like, let's look at this diagram, right? It had some way to split, some way to do map, combine, shuffle, and reduce. We're going to look at it in terms of like, not like a schematic diagram, but let's actually look at it from, you know, how it processes the data. Okay. Suppose you had, so basically, Spark has this notion of RDDs, which is a resilient distributed data set. So you're reading the data into something, into a special format, which is called an RDD. And instead of doing the map operation that we just spoke so far, you know, you do have a lot of different operations such as map and like some reduce operations that you can run on top of RDDs. Okay, so you can read the data into a particular like RDD. Then you can do further down, like further a lot of different operations on it, like filter, like, you know, filter, like you can think closely as, you know, to draw a parallel, just like a filter in a SQL query. So you can take the data, imagine you read a whole bunch of data into a RDD, then you can say, well, all of these are different rows in my RDD. I want to only filter the data that has a certain, you know, a certain keyword. You can add your own logic. You could code it to kind of read only certain lines, or like discard a few lines from your RDD, and then you can apply map to it. Then you can apply reduce to it, and then you can get back the result. Okay, so this is basically what Spark does. But what happens is that at every single stage, whatever, so every RDD, you apply a function and then you get another RDD, you apply a function, you get another RDD. So Spark does maintain this lineage on what, like what, oops, okay, sorry, did something happen? I thought I was sharing my screen. Is somebody else sharing my screen?
Yeah, sorry, I basically hijacked it. I have the PowerPoint version, which is a little bit clearer.
Okay.
So I can flip the slides for you.
Okay, perfect. Sorry. Cool. The next slide, please. Yeah. So, like I was saying, you can run a whole bunch of like map and reduce functions that, like, these are the stuff that come with Spark. So you're able to write, read a file and do a certain operations. So all kind of map operations that you could do, like filter, like group by, like sort, like union, join, all of these are, you know, typically the queries that you can run. All these queries can be grouped into map like functions and reduce like functions. So in your head, it's like you can translate almost any SQL query that you're aware of. If you, I mean, I'm telling this because you probably know some SQL, and you're able to kind of like, you know, somehow map that to the syntax of Spark. But if you're not coming with a SQL, but you're just doing, you've done a lot of like this other kinds of jobs in the past, you could still think about it as like, you know, I'm running a bunch of functions. For every function that I'm running on an RDD, I get a new RDD, right? or every function that I'm running on a data frame, we'll look into it. In data frames, how I do get another data frame. So basically, you're reading a file into a format, and then you're applying a whole bunch of functions on top of this. So if you look at this small example here, the small code snippet here, you have sc.text file, which is reading the file. Then you're applying a flat map, which is a kind of like map function, where you're actually taking basically each and every line from this text file, you're splitting it by certain I guess space, so you get each word of it. Then you're trying to assign one. Remember, we just spoke about how mapping we do, and we assign one to every word. So W stands for word. So you're writing a lambda function that says for every word add a one, and then now you have several words and several ones. So now you somehow combine it for every key. You're able to kind of take that and add up those and add up the ones. Suppose I have the twice, I will have the one. So then this, in the reduction operation, you'll have the 1 + 1 and 2, right? So, and then you can finally save the text file as an output. So this on the left hand side, you'll see some code. This is the kind of code that you do to run a word count operation if you were to write it in Java or Scala. But there are also other ways you can run it using software such as Databricks, where you can quickly start running queries. So what is it in for you? You are going to be learning a new syntax like this that let you write Spark code to do the following operations. So once you learn Spark, you'll get really good with what like map, flat map, reduce by key, all these other functions, and you'll be able to translate any job that you want to do in terms of these functions that you can learn. Okay. Spark is also kind of like fun. It is functional in nature, which means that every time you run the job, you're running multiple functions on top of like the data frame or the RDD. So you're always going to keep applying functions, right? So it comes from the fact that Scala and Spark is functional in nature. So you keep applying functions on top of each other until you achieve a goal. Okay. Next, please. Yeah. Okay, cool. This is just to say that you're reading. This is just how a syntax looks like. So there's no need to get this does not have to be intimidating at all. For those of you who are looking at it, it'll get very, very natural for you, because some of this are just things that you'll end up writing anyway. So every time you write Spark runs it in this context called Spark context. SC stands for Spark context, and then you'll provide a file name and read it using this method. That's exactly how you read. It's nothing fancy. It's just Spark syntax. You'll read it into a variable called lines, and then you will take this lines and apply a function. You see how I was just saying that Spark is functional. So you apply a function, you get something else, and then you apply another function on top of it. Here you get errors, and you say errors.map. You apply another function. So you keep applying functions. It's almost like a chain, right? So then the first step, you read it into lines, and then you're trying to filter out everything that starts with an error and keep and put it into this variable called errors. And then you're going to do furthermore operations, like you're going to do another lambda for splitting it and taking the second variable, like splitting it by tab and taking the second variable. And then you're going to do some cache operation and so on and so forth. And you're just going to do a count operation in the end. This is exactly how a Spark code looks like. So if you were to run this, say in SQL, it would be very, very easy for those of you who know SQL. So it's almost like reading some data, doing a where clause, and doing a count, okay, on a particular keyword. Okay. So how does Spark do all of these things? So let's see. So, so the reason why I'm always talking about SQL is not just to draw a parallel for you to understand this in your head, but also in general, right? Spark reads it into a table-like structure, and it does exactly similar operations like that of like a SQL engine. So for SQL engine, every time you do a query, the SQL engine creates a particular plan, right? In the compiler, there is a upper compiler and a lower compiler, and they're responsible for basically coming up with a plan, optimizing the plan, and rewriting the query into a way that is most efficient. Okay, I'm talking about really huge data, like queries which are 300 lines or 400 lines, right? So you whether you write efficiently or not, the query is passed to the compiler. The compiler basically makes sure that it comes up with a logical optimized plan, and then it basically comes up with like a bunch of plans, and then it decides which way to go based on certain criteria, based on cost or fastness you want to complete or whatever it is, and then it kind of creates the plan for you so you can run and get the result, right? So exactly the same stuff. So there is a Spark framework basically for every time it does a join, like combining two data frames or combining two RDDs, right? It does all of these things in the background. So Spark makes sure that it comes with a logical plan. There's a logical optimization of physical planning, but there's also a cost-based model on how it chooses one plan from a bunch of different plans, and then it generates that code for you. Okay, so think about this. Something like this would then be converted into something like this, which means that Spark will make sure to do very smart operations in such a way that it's able to push certain operations down to a particular either at a database level or either at a column level, so you're getting the best output outside of Spark. And these things are very common because when you deal with really large data, I mean, imagine running a query and not like having to wait for 15 or 20 minutes for the data to arrive, right? So those things need to be sped up, but you can only speed up so much because you're also kind of doing a lot of parallel computing, but you also want to make sure that you're able to do certain things mostly at you're able to push down some of these transactions down to at a column level or at a transaction level. So next slide, please. Okay, so let's actually look at some hands-on code. It might look a very, so far since we did the intro, it might look like a lot of it is kind of like not understood, which is fine. I think a lot of things will get clear as we do a lab. The first time around you learn these concepts, so they're kind of new and kind of like, I think the thought process is different. Once you get used to doing a bit of functional programming in Spark, I think this will all become kind of easy for you to kind of understand and grasp. So we will look into an example. Let me share my screen now. Actually, I just want to make sure I have the, okay, I do have it here. Do you see my screen? Yeah, I think you see your screen. Okay. So what I did is I went into Databricks Community Edition. Okay. Here's the one. I signed up for it. I'm sorry, I don't want to log out, but say I open an incognito window. I just say Databricks Lab Community Edition, right? So you can create and sign up for it with using your own personal email. Databricks is basically a service that's given to you for free. Databricks is a company that gives you Spark as a SaaS service. Okay, so they give you a free community edition with limited amount of resources, with just one cluster that you can create, so you can run and play around with Spark basically, right? This is how it looks like the moment you log into Databricks. So So you have the ability to create notebooks, right? You have the ability to kind of like, I mean, let me show you this first, okay? So Databricks gives you this nice interface where you can, it gives you a workplace where you can kind of like keep track of all of your projects and, you know, code, but it gives you this ability to create, right, a cluster. So this is exactly what I was saying. A Spark, you can go create a cluster and you can create, I don't know, something like test cluster. You can say, please run this, please install this software on it, like run Spark 3.2.1 on it, whatever you wish. You can give further more things if you really want to, but these are default settings. Basically, it gives you one driver with so much memory and 2 cores, you know, and you can click on create cluster. It gives you the ability to only create one cluster at a time, which is why I could not create another one. I already have one running. So this is how my cluster looks like. So it makes sure that it's getting you this from an availability zone somewhere in US West. That's basically where the data center is located. And once it installs Spark, once it creates the cluster for you, the cluster is basically created. You don't have to take care about it. You don't have to go procure it. It takes away all the headache of infra from you. And all that you're given is a very nice Spark cluster. And this is how your Spark UI looks like. Okay. So now, so we'll learn more in the course, but when we talk into detail about how Spark works, but essentially Spark basically makes sure that it comes with a UI where you can monitor a whole bunch of jobs. Every time you run a job, it gives you this nice interface where you can see a job and look at graphs and see how long it's taking and so on and so forth. For every single job, it gives you a bunch of like different stages where you can go look at the stages and see how many smaller, like how it's breaking it down into multiple tasks and how they're all running. You can look at the environment, see it's giving you everything, how it installed. Although you can't physically see a cluster, but it's not something that you basically install it yourself. It tells you, well, after installation, where the Java, where the Scala version is, what it did, a whole bunch of information around how it kind of set up Spark and Databricks on Databricks, okay? These are Spark properties, also some resource properties and other system properties. So basically, you don't need an admin to do this. It's kind of nicely taken care of that all by itself. You can open it in another one. It also kind of gives you other things that are necessary. If you're streaming in data to Databricks and you're doing Spark streaming, which is like doing transformations as you're streaming data, you can also see some streaming queries within the UI. Anyway, long story short, I'm just trying to say that it's installed everything for you in this cluster and it has all of those details for you. Okay. Yeah, so you can also kind of create a lot of other workflows, but for that you will need a Databricks subscription. It's not available for free. But again, what this essentially does for you is it gives you a way to go and play around with Spark to begin with, get used to the syntax, do a lot of like toy projects for you to get used to. So it's really good to have this community edition login for it to go and play around with. In fact, they all suggest, Databricks suggests that you have this because every time you go to Databricks and say you look at a blog, right? I'm just randomly, I didn't plan for this. I'm just randomly picking one of them. Okay. So, and I'm going to say engineering, data engineering, and I'm going to say, you know, I don't know. So I'm just going to looking at tutorial. And if I say something like that, okay. Usually you'll see that most of these Databricks tutorials come with a notebook, right? They come with a notebook that looks like this. Okay. This is exactly how Databricks wants you to learn. They, in a way that they're giving you the incentive to learn Databricks without having to kind of maintain the infrastructure yourself, which means a big headache is actually taken off your head and you can start really querying. So they give you this notebook on purpose. Mostly all blogs have a notebook. What you do is you simply go take this notebook and you say, I'm going to copy this, done. And then you would just basically come here and then you would say import, and then you would pass this URL. Okay. Okay. So now I do have this new thing, this new file available on my workspace, the same thing inside of my workspace. So it also gives you this ability to share your programs across like between different people or from their own community. So you get to start working directly with the notebook. So in a way, it's like learning a new querying tool or a new, a scripting tool, or, for a lack of a word, or a new a tool with a set of APIs or functions for you to run on the data that you're accessing from the DBFS or the Databricks file system, or, like how we spoke about HDFS. There has to be a file system or somewhere that you're keeping your data. It could be an S3 bucket. You could mount an S3 bucket, or you could mount an external storage, whatever it is. But this Databricks gives you the ability to connect to that data and run a bunch. Instead of running a bunch of queries, you're just going to run a few, Spark commands to kind of process that data, right? So that's what we're going to be doing today. So we'll actually look at an example today on how this thing runs. Okay, so now the first and foremost step is for you to go and create a compute. I created a compute the cluster here. I just called it test. I mean, why not? I mean, I just call it test. So for every notebook you simply go here and then you connect it to test like that, right? I'm just going to say restart. I'm just going to connect it. And then I'm just going to say, right, you can connect to it. It had stopped down, so I just restarted it, and then you can start running each one of these nodes. So each one of these nodes, each one of these things is called a cell. The cell is where you will put in your code and you'll start writing your code. Okay. All right. Any questions so far before we go? Okay.
Excuse me, can you do again how you arrived at this page?
How I arrived at this page?
Yes.
Okay, so you go to your Databricks community, you create a user ID and a password, and you create a login, and you log into this, okay? So when you log in, you'll see these things, right? You can go create a notebook yourself, which means it'll give you an empty notebook. You can go create a notebook yourself. Or I think Shawa had shared a link to a notebook, which is this notebook, right? You would simply go, sorry, where was I? Yeah, you can simply go and go to your workspace. First time, this will all be empty. You probably don't have any one of these data files. So you just go right click here, import, and you will upload either the DBC file or you will upload a URL. Okay. I just showed you how you took this URL and you added to it. So you can basically do the same thing. You can go import and either upload a URL or you can upload a DBC file. DBC file is basically an extension for Databricks.
Okay, perfect. Thank you.
Yeah. Okay, so now it's connected. So now all that I do is I start running each and every cell. So when I run each and every cell, it kind of runs the code. Okay, I can run a cell like this, or I can do a shift enter. Okay, so okay, we spoke about RDDs and we spoke about data frames, but I'm going to stick to data frames because Spark, initially the very first few versions of Spark read the data into this data sets called RDDs, which stand for resilient data sets, distributed data sets, but they're not the most efficient way of doing things. So today you'll see that data frames are the most is the way to kind of read data into Spark. Okay. So for those of you who have some Python experience in the past, you probably have heard about pandas data frames. That's similar. A data frame is like a representation of a data that looks like a matrix. Okay. So imagine you have a CSV file with data. You have certain columns and you have certain rows. Imagine the same thing. Okay. It is like a data frame where you have certain rows and certain columns and you're reading the data into it. Okay. So you could have a file that's very well organized and very clean, where you have a fixed number of columns and a fixed number of rows, and you can read into it. Sometimes you might even have, a data frames like data that's not clean, in which case you can tweak it a bit to kind of read it into a data frame yourself, and then you can create a data frame from the scratch, or you can read a file into a data frame. You can do a lot of those operations. Okay, so we'll actually see how that works via Spark and learn about that. Okay, so Spark does have a lot of functions, and they're all in terms of like data frame. You create a data frame, you empty a data frame, you read it, you read it into a stream, then you apply a bunch of different filter or like group by or whatever you want to apply. All of them happen on data frames, right? You apply an operation on a data frame, you get another data frame. You apply another operation on a data frame, you get another data frame. Okay, so similar to the stuff that we were speaking about, it's all functional in nature. It all happens as a chain, like you're applying a chain link to each one of those things. So Spark session basically provides a single point of entry to an underlying Spark functionality. So basically, every time you write Spark code, you have to initialize a Spark context or a Spark session, which will then open up for a Spark context. So that is just the syntactic details. You would understand this much better if you wrote Spark from the scratch using Java or Python, Java or Scala, and you compile your code yourself. But since Databricks has made our life easy, we don't have to bother about that. We just simply say from PySpark.sql import Spark session. So you import a Spark session and say, here, I'm starting a Spark session. Okay, this is exactly where Spark will start running. And then after your Spark is finished, your Spark job is finished, the Spark session gets closed, or you can close it, or you can write code to kind of close the session. Okay. So basically, any Spark code starts with creating a Spark session. So now we do have a nice implementation available. We simply start Spark session, and we start and give our app a name. In this case, my app name is free data course. App name is just like a placeholder to say, hey, we're running this. It doesn't matter. For Spark, you can name it whatever it is, and then you create a Spark session. And then the next thing is to get a Spark context. Okay. Okay. So that's basically what you would do at every given step. Then actually comes the processing of the data. Now, your data can come from any place. Your data can come from a CSV that you're reading from some file system. It can even be a JDBC or an ODBC connectivity to a table that you're reading from, which probably is very, very common to most of you people. You're probably always connecting to some kind of a database to read data using any software, right? You could read a file that's already existing in another format. Not quite sure, but there are a lot of different formats that are used in the big data world, like ORC, Parquet, Avro, a lot of different files, right? Needn't always be text file. Instead of CSV file, it can also be a text file that is tab separated or comma separated. You can give it whatever you want to. You can give you can give it all the details you want. You can say, well, I'm reading a tab separated file. My delimiter is a tab. I'm only interested in reading the second and the third column. You give it whatever you want to. You can basically program it to read the right way and then read it into a data frame. The moment once the data is in a data frame, now you're free to write Spark code to do whatever you want to, right? So you can also provide a schema. Sometimes, you have like a CSV file, but you don't have the column. You just have plain values, but you probably want to enforce a schema yourself onto the CSV file or whatever file that you're reading, and you can enforce a schema as well. So there are configuration methods where you can give that schema, where you can specify key values, where you can specify a map. You can do all of those things. Okay. Again, these things you'll get used to the more and more you run, but I'm just saying that you do have these capabilities. Then you do have some data here. So this data is basically some, telecom CDR data, which is already stored in this location. Do you see anything here special? You see that the data is actually in S3. So it's really cool because our data is actually in S3. I'm sorry. Our data is actually in S3. which is which is basically how AWS stores data in some buckets, and you can basically mount that to basically Databricks for it to understand, okay, if I'm going to be reading data, I'm always going to go read data from a certain location. Okay, and this data has a whole bunch of information. It's just some telecom information with some kind of IDs and time interval and codes, and so some SMS activities and call activity on your phone. Okay, so basically I can do all this, right? I can do git clone as well. Sorry, what just happened? Okay. Okay, so I can do git clone from another data repo as well, and I can load it into my Databricks instance. The moment I do that, I do have my data available onto my Databricks instance, and I'm able to read it. Okay. So also note that we're able to run a whole bunch of operations like ls, like git, that you would run on your typically on your command line if you were running either Linux or Windows on your command line, right? So it gives you ability to run some system commands as well, along with some Databricks commands. Okay. Okay. Right. So that's one thing. The moment you can put the data in some CSV location, right? What just happened? I'm just going to run all of them. Okay. Okay. So that's how you do. Okay. So then once you do that, what you do is you start reading the files you start reading the files and for the schema. So the way you would write typically a file is you know, you can actually go look up for pandas. Pandas is one of those Python data analysis libraries. You can go look at the user guide or API reference. And if you wanted to read a CSV file, right, you can simply say pandas read CSV file, and it gives you actually how you can read. Sorry, let me look at another example. Okay. So it basically tells you how you can read a CSV file, right? So if you were to read a CSV file into a pandas data frame, it means that you are going to be reading CSV file into a data frame, and you get this data frame called data frame. So you have a similar concept in Spark as well. You also have Spark data frame, which is similar to this. Okay, Spark data frame. Okay. So you can go, Spark has a really good guide. You typically go to data frames, and you would go to sorry, data sources. Suppose you're reading a CSV file, I can go and say Spark data frame. Just go to the Python one because we're reading in Python. See here how it start. You start a Spark context. You're reading a CSV file. Then you would reading a CSV file into Spark, and you say data frame.show. Okay. So data frame is this nice tabular structure where you're reading your data into like a table-like structure where you have fixed number of columns and rows, and you're doing the same thing in Spark as well, just like how we were doing it in pandas. So right now what I'm trying to do here is I'm going to read this into a pandas data frame, and then I'm going to parallelize it. So parallelize is a method where you would convert this data frame into a Spark data frame. It's actually making it like one of those things that makes it like when you run a parallelize, it means that the data frame now is something that Spark can run on because you're able to run them across different nodes. Remember the whole word count example where we were doing a whole bunch of operations again and again in a repeated fashion. It's like making it readily available to do that. Okay. Next thing what you would do is yeah. So basically you can also do other things. I'm just going to quickly go over this notebook for you to understand what all are possible. And then I will share this example for you so that you can run it. The next thing you typically do with a CSV file is to run using like run the same thing. Instead of reading a CSV file, you can also enforce a particular schema. So when you read something into a CSV file, right, you see how there is a file here. It just read because it did not have certain columns and it's not inferring a schema from a file. It gives it random column names. So if you don't want something like that, you can basically enforce a particular schema and say, well, read me a CSV file, but because I have all of these values, I'm going to rename them as square ID, time underscore interval, country underscore code, SMS underscore in underscore activity. You can give it its own name, and you could give it its own value, like a data type, for as if it is an integer or a long or a float or whatever it is. Okay. So basically then you can simply say, instead of read CSV file, you can then say read the same file, but please make sure you use this schema that I just gave. So you can basically give a user-defined schema to the file and read it. Okay. Okay. Cool. Any questions so far? Okay, so this is how a syntax looks like, right? So all that I want you to look like right now is not to kind of overcomplicate this at all. I just want to look at the syntax and just get comfortable with it. Okay. So and then we can do a whole bunch of other things, right? So I'm just going to run this again, but just look at the scheme of syntax for now, and then we will run it again. Okay, so now if you have already a CSV file, but instead of reading a CSV file, if you want to write the CSV file, you do have ways to write the CSV file as well. So you can simply take a data frame and give it some write operation, like give it some options and use the write method to write the CSV file either into a CSV file or a tab separated file. You can specify the delimiters, whatever it is. So if you are in doubt on how to do this, you would simply go and say sparkdf write to CSV, and it'll simply give you, you should have some code that gives you how you write it into it. Okay, so you can write it into a CSV file, or you can provide a format. You have all kinds of documentation to do that as well. So it's just a matter of providing it the right amount of I guess options. Okay. What you can also do further is you could yeah, one second, after you read the file, you could also do cache, which means it can cache certain data frame to do further operations. You could do things like count, which will tell you how to kind of like basically count the number of operations. You could remove the data from cache by using this unpersist method. Then you can also do take one, which means it will take the first column, first row. You could also do a bunch of operations like show, which will actually show the different the data frame. Then you could do a count. You could display the data, and you can do a whole bunch of transformations like select. Let me actually show you that in a minute. I'm just going to stop sharing my screen. I'm just going to run this quickly, and just give me a 1 minute. I'll give you a 1 minute break, and I'm going to fix this and then get back to you. Clone. Okay. Let me actually fix this. Shawa, are you here?
Yep.
Yeah, I think, do you have the SMS CSV file available?
Which file?
The CSV file, the data file.
Yeah. 1 second. Let me send it to you.
Yeah.
But you can download it from the notebook as well.
Actually, I'm just going to download that and upload it myself.
Okay, 1 second. Let me show.
Okay. Data. Okay, okay, folks, I think I have it fixed. Excuse me for this last minute change. Okay, I did upload it. I did upload it into another file. Okay, so I'm just gonna go ahead and share my screen. So this is how it looks like. So I can basically have either a file that I'm loading it into. I'm loading it into a certain location on my file system. I can read it as a CSV file. I'm specifying it as a file type as a CSV file. So I do have this raw data that I'm reading into. So I can have multiple CSV files that I'm storing it somewhere, right? Imagine I can either put it in on a file system and then mount it and read it, or I could have it on GitHub and then I can get it from GitHub. In this case, I put it into a file system within Databricks, and I'm specifying all the different options that I have, CSV options that I have. I don't have a particular schema on this, so I'm going to say false. I'm going to say my row header is so and so, my delimiter is so and so, and that is how I read it into a data frame. Okay, I can say I can say here's my data frame. I can say spark.read.file format. I'm going to provide it a file type, which is CSV file. I'm going to say whether I have to inform my schema or not. I can say, here's my header. I can say, what is my separator or the delimiter. And I can say, how do I load from where do I load my file? In this case, I have my file here. So I'm actually loading it into here. And then I can display my data frame. Okay. The moment I display my data frame and I run like this, right, I get this particular data frame, right? So now I can run whatever I want on my data frame, right? I can run it. I can run whatever I want on it. I can say I can say data frame. This is my data frame, so I can say something like I can say df dot and see, it's showing me exactly how many records are there. I could do some basic operations like df.show. So df.show is just a method that shows me the data frame. Then I can run several other operations such as I don't know, Databricks, sorry, df.select. I can run certain select formats. or I can say drop certain things. So you can apply those functions, a lot of them. And the way you do that is you would go ahead and look at data frame operations. I'm just going to show you from Spark. You could go to a guide, right? You typically go to SQL. So you have all of these different operations that you do. You can create data frame. You can say create data sets, run a particular view on it. How do you write SQL on it? If you want to write SQL, how do you do on it? How do you then enforce a particular schema on it? All that, right? So depending on what language you're using, you typically go to your Spark, I guess a documentation page, look for the Python implementation or the API, and look and do that kind of a query that you're interested in. Yeah, that's basically what I wanted to talk about. I do already, I think I'm gonna, the other thing that I also want to show is I want to probably show the workspace here, and I want to show some basic tutorials, right? You can go here, look at some basic tutorials, and they will actually give you a lot of nice tutorials on how you can visualize data as well as run some analytics. Suppose this is an existing notebook that I have. So this is about some kind of a data set that's already publicly available. It's something to do with diamonds, and the data is basically already in a CSV file. So you can simply read the CSV file. Just like last time, how we read the CSV file into a data frame, I could also read the data file as if it was a table, and I'm going to read it into a table, and I can create some commands as if it was a CSV file, as if it was a table, using that CSV file. All that I need to do is I need to pass the CSV file, and I'm going to say create a table and run it. Right now I have the ability to run SQL commands as well on top of the data frame. So I'm just saying select star from whatever my table name is, just because I created a table called diamonds here, and then I'm able to run a lot of SQL commands, right? I'm also able to do other operations using Python as if I'm reading this file, and this time I'm not doing a SQL. The reason I'm actually showing you the two different queries is that the first time around, I actually read it as a SQL table. The second time around, I'm actually writing it as a data frame and writing it out as a data frame. So you can write basically both in both ways, whatever you wish to. Okay, so there's a lot of different things that you can do in Spark. You can also drop a table if you wanted to do. You can do selection operations, you can do projection operations, just like how you would do in a table. You can do that using SQL, you can do that using pure Spark API. Okay, here's a small snippet on how you can run an order by. You can also do things like how you would read schemas, and infer a schema. So this is in Python, right? And then you can say, you can do some graphs, and you can display some results as well. Here it's trying to show certain colors and prices and doing group by and aggregation. So that's how you do it. So it's almost like learning a new, just like learning SQL, you're going to be learning a new framework to do all these operations. Okay, so this is some basic things with Databricks in 5 minutes on how you can read some data, do a lot of operations on it, either do operations using SQL, or either you do operations using Spark API. SQL is okay to do it if you are quickly looking at the data and doing a quick analysis of the data, but most probably will be learning Python, PySpark syntax on how to do a lot of these operations. So you won't be mostly writing in SQL, but the idea is you'll be writing it in Spark API. It's good to learn that, because now if you want to compare your results using SQL and Spark, that's like a good exercise to kind of do, so you know you're doing the right thing. Any questions so far? No? Shava, you want to add anything here?
No, we have still have about 15 minutes left. Thanks
Yeah.
everyone for joining this session. I wonder at this point if you have any questions regarding big data and Spark, or anything, any questions about for example, data engineering job market, or skill sets required, any career guide, since we have Indrani online today. Feel free to ask any questions you have. Feel free to unmute yourself, or just send your question to Zoom chat. Yeah, the recording will be available tomorrow morning, and we will notify everyone on Discord. I'll send you the link to join our Discord so you can stay up to date about our future events, and also all the the recordings of our free data classes. You can also sign up for an account at learn.weclouddata.com and join the free data engineering course. The recording will be uploaded there.
Hello. Hello.
Oh, I
Hey,
had a
hi.
Yeah. Okay. So question. I was wondering about so if we using the AWS and then the Azure, right? Then the thing is, why do we need to have to using the Databricks? It's instead of we using the other notebook already installed in the AWS. I mean, in the AWS, they have like a SageMaker, right, or something like that.
Yeah, good question. I can answer that. So SageMaker is not okay. So SageMaker is something different. SageMaker is a managed service that lets you do some machine learning models on it. But in order to run Spark, you can do it in multiple ways. You can create a job, write it by hand using Java or Python, and then submit it to a cluster that you would create as an EMR cluster. If you look at our where was our let me first open up that sorry, do we have access to the 1 second, let me reopen that Zoom link. Okay. How come I don't have it? Okay. 1 second, folks. I'm just going to come back to it. It's taking a minute to download. My computer is slow and something happened. Yeah, much better now. Okay. So you're looking at this EMR, right? Let me really show my screen. So this is my screen, right? So you see this, how we had multiple different components within AWS. So there is this managed service called EMR, which is like your basically a cluster where you can run your Spark code on. So you can basically run your PySpark code and submit it to EMR and run the Spark job. So it will take care of the operations yourself. Or if you don't want to do that, you can go access a service such as Databricks that is not going to be one of those things where you will have to go procure and stand up your EMR yourself, which means you're not going to go to AWS requesting for an EMR, giving the configurations and saying, I need this big of a cluster. I want, a certain version of Spark to be installed. You would just go to Spark. You would just go to Databricks, create your cluster yourself, and run the query and run it as a notebook. So both of them are possible. You can do both ways. There's multiple ways you can do Spark, depending on where your Spark is or where the infrastructure is. If it's not on AWS, if it's on Azure, like you said, you could have another cluster on Azure as well and do it there. Azure also offers another service called Synapse. You can run there, or you can run it on Databricks. Azure has Databricks as well. You can run there. So what we want to concentrate in this course is that you learn the syntax for Spark. So you can go and deploy this in any environment you want. Does that answer your question, Juan?
Yes.
Yeah. So by the end of this course, you should be able to run Spark code, install Spark on your computer, run it on your computer, or you open up a cluster, run it on the cluster on top of like AWS, or you're able to run the code on Databricks. So the key is learning the syntax and getting used to the framework, and deployment strategies will also be discussed. We will also, like, throughout the course, there is also a project where you will see multiple ways of deploying it. You don't want to deploy it on the cloud. You have Docker images. You can do that as well. Okay, there's a lot of new concepts in this course, guys. So just want to say that there's a lot of patterns, and you'll learn all of these patterns as well. Any other questions? It's a pretty silent class. No other questions? Cool. We do have 10 more minutes time if you want to ask any questions.
I think some folks got some issues, creating a Databricks community account. I can quickly share my screen and help everyone get started.
Okay.
So to sign up for an account, you need to go to Try Databricks. I think you'll see this this page. Just fill in your information and click on Get Started for free. And then it's going to ask you to choose a cloud provider. You can choose AWS by default. If you prefer to, work with Azure, Google Cloud, it's pretty much the same. However, instead of clicking on the blue button, Get Started, you do need to, click on, this small link at the bottom instead. So click on Get Started with Community Edition. It used to be a separate sign up page, but I think now they're just trying to encourage people to all sign up for the free trial. So if you click on the blue button, it's a free trial, and then it's going to expire in I think maybe 2 weeks time. But if you would like to keep using the Community Edition for learning purpose, do click on this Get Started with Community Edition, this gray link at the bottom, and that should take you to a page where you need to do some sort of verification. Just in this case, pick the snake, and then it will send an email to you, and you just need to verify your email, and then but I've already created an account, that's why I see the error. But you should be able to get an email and get started with the Community Edition.
Yeah, cool. I don't mind showing another example if we have time, folks. So I'll just show you quickly another example of another notebook. So if you see here, I do create Okay, so here's the thing. Okay, I'm reading some data. So from some kind of geographical, it's geographical information. They're all in the form of CSVs. So I'm reading a file which it's all data about taxes. So I'm reading it into a particular data frame, and then I'm also having some market data, which I'm reading it into a certain data frame. Right? I could basically create and replace certain views on top of this data. I've done some SQL analysis on it, looking at the tax data. I can do some analysis. I can look and do some analysis by zip code. That's what I've done here. I've created a new table, a new view on top of it. I can do a whole bunch of operations where I can clean up stuff, and I can look at the data. Or if I don't want to do this, I can also do things like doing let me show you exactly some maps and flat maps. So here I have some words here. I just made up a particular data frame, sorry, an RDD. I'm running a flat map where I'm trying to split each one of them by some space, and I'm collecting them and storing it as an output. Here, that's what was my output. So I do have some random words. I'm splitting it. I'm just running a flat map. This is just to show different kinds of functions in Spark. I do also have, we were also discussing about parallelize. Parallelize is this function where it makes it available for your clusters to run it in a distributed fashion. So I can basically parallelize a data set of different numbers. I can also do operations where I would do typical operations like union or join or intersect, that kind of operations. Suppose I do have some words, all those people who have Java skills and who have DB skills, I'm able to do a quick intersection, and I can run intersection. Okay, I can do a quick union. I can and do operations. So everything that you can typically do in a database, like on a table, you're able to do that using Spark. Now, the new way of doing things is using data frames. So we'll stick with data frames. But that said, you can also run and check for yourself in RDDs if you want to. Okay. So yeah, I just created by hand some group by operation where I wanted to show purposefully a map operation. I do have some input data where I have some kind of numbers here. They're all in the form of, a key and a value. So I do have London's, I have some number, I have Manchester, I have some number, I have Leeds, some number. I'm grouping them by key. So you already know that there are two times, this 2 times that London has occurred here. So I'm actually going to do a group by operation. So for those of you who know SQL, when you do a group by operation, you're always going to follow it using some kind of an aggregation operation. So I'm just doing a sum here. So I'm trying to add up these 2 values. So I'm just going to group by key. Then I use a map function. I run a lambda, and I'm doing a sum operation. So the result would be the sum of these 2 for those keys that I'm doing a group by on. So I'm going to be doing a group by on a key, which is and therefore I have the result wherever London comes in, I have 50. Okay, so just basic group by operation, but you're running it using some code, right? Yeah. You could also be doing it using reduce by key. There's a lot of these things that you will learn, and you'll get used to the functions that are specific to Spark. Okay, as you would learn more and more, and that's basically what we want you to kind of get good at with, right? Yeah. So I think this lambda, this map and flat map, those will filter. Those will all become second nature to you as you learn Spark. And then you also have the additional benefit of course, reading data in the form of tables, which we already saw earlier in our diamonds example, where we saw how you're going to read the data into a table, and you can then do a lot of different operations, either in SQL, or you can either do it in code. Okay. So that's an additional thing that I want to touch since we had some time.